In grading your quizzes, I noticed that several of you are still struggling with law of cosines. Some of you actually left all three of the questions blank. Several of you had varying degrees of success with finding the correct answers for these. So let's work through this example from our test review to give you a little help with understanding the law of cosines. We use the law of cosines in two cases. We use it when we have side, 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 that is we're given all three sides of the triangle, or when we're given two sides and the included angle, SSS. We frequently will draw a picture of the triangle to visualize which of these cases we have, but in the case of side, 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 it's fairly obvious, and that's what we have here. This is side, 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 so we will use the law of cosines. It's critically important when we use the law of cosines that we first find the angle opposite the longest side. In this case, the longest side is side A, so we're going to find angle A. The formula that includes angle A, it's the one that ends in multiplying by cosine of A. It begins with A squared. So in this case, 14 squared equals B squared plus C squared. So in this case, 9 squared plus 6 squared. And then from that, we're going to subtract 2 times the product of those two sides, in this case B and C, so 9 times 6. And then we'll multiply by the cosine of the angle we're looking for, in this case A. We'll start by simplifying the number portions. We have 3 different sets of numbers that we're going to simplify. The first one, 14 squared, is 196. We'll set that equal to the difference of 9 squared plus 6 squared, which is 117. From that, we'll subtract this product, 2 times 9 times 6, which gives us 108 times cosine of A. Now, this is the first spot where you're likely to make an algebra error, and that is with order of operations. Some of you are going to want to do this subtraction now, but that would be a mistake. Order of operations tells us that the multiplication would have to take place first, 108 times cosine of A. So in solving this, we're first going to subtract 117 from both sides. 196 minus 117 gives us 79 equals negative 108 times cosine of A. Now we'll move that negative 108 to the other side by dividing. We have negative 108 times cosine of A. We'll divide by negative 108. And one of the other mistakes that I saw in several of your quizzes was neglecting that sign. It was as if maybe you were thinking of it partly as an addition, so it became positive when you moved it to the other side, but this is division, so that remains negative, and we're left with cosine of A equals 79 over negative 108. Yes, we could move that negative sign to someplace more appropriate, but again, it doesn't matter. We're just going to be plugging it into the calculator. Next thing we do is we isolate the A by taking cosine inverse of both sides. So we get A equals cosine inverse of 79 over negative 108. And this is what we'll put in our calculator. Do not put this fraction in your calculator first and round it. I'm not sure what we get with this one, but if you round at this point before you take the cosine inverse, your answer on the quiz, some of the answers were off by as much as 3 or 4 degrees in looking for that angle, and that is not an acceptable rounding error. Remember, we only round once, and it's the very end. So we're going to put this in our calculator just as it's written on the page here. Cosine inverse of 79 over negative 108. Now, our directions on this problem didn't tell us what place to round to, so I'm going to make an assumption, and I'm going to round to the nearest tenth. Now, in my calculator, When I plug this in, I get 137.01073607. The important parts of that are looking at the hundredths place, it's a 1, and the tenths place is a 0. So when I round that, it rounds to 137 degrees. I'm going to go ahead and put the 0.0 on there. That's my indication to you that I've rounded it to the nearest tenth. So there's my working measurement for angle A. I've rounded one time at the very end, so that number's not precise, but it's close enough, and we will go ahead and reuse that in our next calculation. Now, since we've found angle A, we now have a complete ratio of a side and its angle, or the sine of that angle. So we can shift gears and stop using the law of cosines, and now we're going to find our next angle using the law of sines. Some of you on your quiz continued using the law of cosines to find all three of the angles. A variety of issues come up when you do it that way. Number one, your rounding is going to be different for each one. Your three angles at the end may not add up to 180 degrees. That's not acceptable. What I want you to do, use law of cosines to find the largest angle in a side-side-side situation, and then shift to law of sines for the second angle. The third angle we'll just use subtraction. So it doesn't matter whether I find angle B or angle C, I'll just do it alphabetically and I'll find angle B. So let's see, we're looking for an angle, so I'm going to put the angle measure on the top in the numerator. So sine of B over B, which is 9, equals, and the pair that we have complete now is A. So I'm going to put sine of A, which we now know to be about 137 degrees, over the length of side A, 14. I put the variable in the numerator every time. That leads to shifting back and forth between the sine being on top or the side length being on top. I just use whichever one makes the algebra easiest, and that is always by putting the variable, which is right here, in the numerator. Now I just multiply both sides by 9 to cancel this out. So that 9 will go away from this side, leaving me with sine of B equals 9 times sine of 137 over 14. And now I'll take, since I'm looking for an angle, I have to use an inverse trig function, and I'm going to use sine inverse since the ratio that I know is sine. So taking sine inverse of both sides leaves me with B equals sine inverse of 9 times sine of 137 degrees over 14. Now notice I haven't stopped to use my calculator at all yet, and it's very important that you don't. If I use my calculator at any point leading up to this step, I'm going to have a compounded rounding error, and again my answer is going to be very often unacceptably approximate. Might be off by a degree or more. So up to this point, no calculator. Now that I have B isolated, I'm going to put this entire expression here into my calculator. And I get an answer approximately, it's actually very close to 26 degrees. I'm going to write 26.0 to indicate that I'm rounding it to the nearest tenth. So now I know angle B, I know angle A. For angle C, I'm simply going to take 180 degrees and subtract the two angles that I know. Minus 137, minus 26. And I get approximately 17 degrees. I say approximately in this case, approximately, even though 180 minus 137 minus 26 is not an approximation, but the 137 and the 26 both are. So the 17 degrees is approximate in the same sense that the other two are. So now I have A, B, and C, 137 degrees, 26 degrees, and 17 degrees. and if I add those all together, I get a total of 180 degrees. Very important check at the end. Some of you gave me on your quiz, I saw several of you, where your angles did not add up to 180 degrees, which is an indication that you did not use subtraction to find the last degree, the last angle. If you just subtract to find the last angle, your angles will always add up to 180 degrees.